Hola, ¿cómo estás? Mommy's turn.
Hi, pre-calc students.
Oh, hola, ¿cómo estás?
Oops, mommy was turning that.
I have a wiggly tooth. Hola, ¿cómo estás?
Do you want to show them your wiggly tooth? Just smile for them. All right, now that the boys are in bed, we're going to take a look at the last type of probability, which is compound events. Again, compound events are two or more events that occur. This time we're going to be looking at OR events, and I kind of talked about those a little bit in one of the earlier videos. Two types of compound events we're going to be looking at today. The first is mutually exclusive events. These are events that cannot occur at the same time. So for example, if you roll a die, you can't get the same outcome that you can get when you flip a coin. So those would be mutually exclusive. Looking at our Venn diagram, those would be two circles that do not overlap at all. And then we'll have inclusive events, and these are events that have outcomes in common. So when you find the probability of mutually exclusive events, you simply add the two probabilities together. The problem with inclusive events is that the or, the union, both, would be an overlap. So you would have the probability of A plus the probability of B, but there would be something, whatever they have in common, there would be something that was double counted. So we have to subtract that out. So we'll see how that works. We're going to start with the easier of the two probabilities. We've got some mutually exclusive events. A deck of cards, what's the probability of drawing a king and an ace? So this is a little bit of a review from our and probability. And when we're drawing cards, we assume no replacement. We're dealing out a hand. So we have 4 out of 52 cards are kings, and 4 out of 51 cards would be an ace. So simplifying our probability, 4 goes into 52 13 times, multiplying straight across, we get a final probability of 663. Now let's take a look at what happens when we're setting up OR probability. What's the probability of getting a king or an ace? Well, on one draw, you can't get a king and an ace. These are mutually exclusive. So we simply add the probability that we get a king to the probability that we get an ace. So this time we're thinking about just drawing one card. What's the probability that one card we draw is a king or an ace? And there's 8 total cards in the deck that would be a king or an ace. All right, so next we've got inclusive events. So these are, again, events that have something in common. So let's take a look at that double counting that I was talking about. What's the probability of rolling a prime? So when you think about the options on a die, 2, 3, and 5 are all prime. So that's 3 out of 6. Or an even number, 2, 4, and 6 are even, so that's 3 out of 6. But if you noticed, we counted the 2 twice. You don't have a 2 out of 6 chance of rolling a 2. You only have a 1 out of 6 chance. So we have to subtract off that 2 that got counted twice. So we really have a probability of 5 out of 6. There's a 5 out of 6 chance of rolling a prime or an even. 1 would be the only number that doesn't fall into either category. And our last 2 examples, we're going to take a look at differentiating between the two. We'll decide if there's any overlap and we need to subtract off that double counting. So what's the probability of drawing a king or a heart? There are 4 kings out of 52 in the deck, or there are 13 hearts in the deck. Are there any cards that you could draw that would be a king and a heart? That's that intersection that would be double counted. Yes, there is one card that's the king of hearts, so we counted that twice. So we have a total probability of 16 out of 52, which simplifies, 4 goes into both of them, to 4 out of 13. All right, our last example, we're going to take a look at the probability of rolling 2 dice and getting a 1 or a sum of 9. So we're going to use our sample space again to help us determine the probability. So what's the probability that we get a 1? Well, we could get a 1 on the white die, or we could get a 1 on the red die. Now these do have that overlap. We're just not going to count the doubles twice. So we have a total of 11 out of 36 chance of rolling a 1, or a sum of 9. Well, when you roll a 1, you can't get a sum of 9. The biggest sum you could get would be 7. So we'll look for those sums of 9, and those are on this diagonal here. So we have a 4 out of 36 chance of rolling a 9, and we didn't double count anything. So we have a total probability of 15 out of 36. And take a look at your 2U try questions.